Hello guys, what's up? We are back again. So this is the last question of today's contest. So let's see what it is. Minimize Manhattan distances. So in this question, we are given an array of array points where points of I is basically two size array xi and yi, and we need to find the minimum possible value of the maximum distance between any 2 points by removing exactly 1 point. And the distance should be Manhattan distance. So the question lies in understanding what is Manhattan distance. So let us see. Just a second. Now, a Manhattan distance for 2 points xi and yi is absolute of xi minus xj plus absolute of yi minus yj. Now, I can open this bracket and can see the expression becomes something like this. Xi minus yi plus xj minus yj, or rather means if I open the mod and take all possibilities, then this will become something like this. Minus of xi plus yi plus xj minus yj, comma xi plus yi minus xj minus y. If I again write it down simply, then it becomes xi plus yi minus xj plus yj, or xj plus yj minus xi plus yi, comma xi minus yi, comma xj minus yj, and so on. Now I can see that there are two terms, xi plus yi, xj plus yj. Okay, so this is minus xi plus yi, this is minus xj plus yj. This also has xi minus yi and xj minus yj. So these terms are simply negative of each other. Yes. So these terms are simply negative of each other. So if I can somehow treat them as one term, this and this. Yes. So I can somehow treat them as one term. So essentially I'm left with only two terms, that is xi plus yi minus xj plus yj, or xi minus yi, comma xi minus yi minus xj minus yj. So if I have these two terms, this and this, then I can very easily calculate what is the maximum out of it and can return R, and that will be the Manhattan distance between those 2 points. So now comes the implementation part, that we will use this fact and implement it using a multi-set. So now what is a multi-set? A multi-set is a set-like data structure only, which stores values in sorted order. Yes, very important. It stores values in the sorted order, but it can also have duplicates. Yes. So duplicates are also allowed in multi-set. So we can use this fact to our advantage and can try and insert all possible. We can have two multi-sets, which one for sum and other for the difference, because a Manhattan distance can be of the type this or difference one, xi minus yi minus xj minus yj, or xi plus yi minus xj plus yj. So I will try and store all possible xi plus yi and xi minus yi. So I have two multi-sets and I will insert them. Now what multi-set will do? Multi-set will have it in the sorted order. Now I will again traverse the, now what I need to do, I need to remove 1 point and find the minimum possible value for maximum distance. Minimum possible value for maximum distance. So I need to remove that and I need to find maximum Manhattan distance between 2 points. Now, what is a Manhattan distance? Manhattan distance is maximum of this xi plus yi minus xj plus yj, or xi minus yi minus xj minus yj. So what I will do is, for I will start iterating this vector and I will remove, yes, I will remove this s and d. So I will remove these points where these are involved, sum and difference from the set. Now in the multi-set, I will find this. Now in the multi-set, I will find this Manhattan difference. See, the multi-set is already sorted. So what this r dot begin will give? R dot begin will give me the last, or in this case, the largest element. So this will give me the largest element, and x dot begin will give me the smallest element. So clearly, this will be the largest difference. This will be the largest difference. So for after removing in one iteration, I removed that, and now I have the maximum Manhattan distance. And overall, I need to find the minimum of the Manhattan distance. So I will use the result. I will take the minimum of overall Manhattan distances. Before moving next, I will make sure that I will insert these. So yeah, guys, this was how we can solve this problem. So let me very quickly brief again. We first inserted elements in this way: xi plus yi pairs and xi minus yi pairs. We inserted all xi plus yi and xi minus yi pairs because we know that that can only be the answer. Then we iterated back in the vector and erased a particular element, and then we find out the maximum Manhattan distance. We know how to find the Manhattan distance, and we are using multiset, which is already sorted. So this will give us the maximum Manhattan distance. Now we need from all these distances, we need the minimum. So we took the minimum at the end. Finally, before moving back to the next iteration, we inserted S and D back. So yeah, guys, this was all. Thank you so much, guys. Just in case you like the video, make sure you hit the like button, press the subscribe button, and share it with your friends. Thank you so much, guys. We shall see you next time.